Hi everyone, my name is Anastasia. I'm a software engineer in Jetpack Compose team, working mostly on text. So in this talk, we're going to take a closer look on text, how it works, and some of the APIs that you might have not heard of. So text is a fundamental way to interact with the application. Badly formatted or poorly rendered text can significantly degrade user experience. Say, it may make text difficult to read. They might even your user just drop the application altogether. So here you can see the chart's main functionality doesn't work for the receiver because they don't really see the emojis. They are not rendered correctly. It would be a mistake to assume that only those text-heavy apps like the News app or Messages or e-reader, the apps that will and should take care about the text. Even apps like games use text for the storytelling, for example, and utility apps use text to convey the information. So what are we going to cover today? So first, I'll make a quick recap, well, maybe not very quick, recap of how text is rendered and what libraries and steps it takes to get from char sequence or sequence of characters to render text on Android, in Jetpack Compose as well. Then we'll have a look at a few APIs that you might find useful in your next Compose application that will help you with the readability across different contexts like maybe locales and different form factors, as well as we'll take a look how to add some text effects and to do custom drawing of the text. This will be a large section because we're going to cover quite a few. And then finally, I'll give you an overview of what is coming to the Compose 1.8 in terms of text APIs and improvements. Okay, so let's begin. So first, let's have a look what it takes to get a string to become rendered pixels on a screen. The rough path can be described like this. Your app requests to display some text. First, the text needs to be measured during the measure pass. To do this in Compose, we call text composable and pass in a string or annotated string to the platform code via the static layout. At this point, we'll do all of the conversion to platform types. Static layout then actually measures the text. We don't do these in Compose code. We use what the team has built over the past decade. Static layout is responsible for multiple things like automatic line breaking, ellipsizing, inline styling, paragraph styling, and other. It also provides the text layout metrics like the bounding boxes of the characters or the line heights. So it also acts as an entry point for the text drawing. We didn't develop everything from scratch on Android for text rendering pipeline. In fact, we use multiple third-party libraries, and to bring them all together, we have an internal library called Minikin. It acts as a translation layer from Java to those third-party native libraries. So static layout calls Minikin. Inside Minikin, we do a few things like font selection, use an Android fallback mechanism, and the actual line breaking. Minikin also does a lot of clever things to improve performance, including caching. But to do the line breaking, we actually need to know how much space those characters will take, quote points will take. And this process of translating a sequence of characters, or strictly speaking, Unicode code points to the glyphs that can be rendered is called shaping. We actually cache a lot of shaped words in Minikin. At this point, our cache size is 5,000 shaped words. And for shaping, we use a library called Harbus. We also use another third-party library called ICU that provides Unicode data. We need it for multiple things. For example, for bidirectional support. This is when you have left to right and right to left characters in one text. We also need it to find breaking opportunities for line breaking. I'll talk a bit more about this. And finally, when the text is measured, we can draw it during the draw pass. And at this point, during the draw, we actually perform another shaping to actually get the final glyphs, shapes, and positions. And we do text rendering using Skia library. This is a 2D graphics library we use on Android to render onto screen. And under the hood, skiers want more library that is called FreeType that does the rasterization. Okay, so in reality, this whole process is a bit more complex, but these details are not really that important for the context of this talk. Okay, so as you can see, there are lots of steps and libraries involved in text rendering. So you might be wondering, why do we even need so many? Where the complexity comes from? So let me give you a few examples. So say we have a ligature in our text. Ligature is when 2 or more code points result in a single glyph. So we don't have a one-to-one glyph to code point to glyph mapping anymore. So we need to take care of it. And then if we apply letter spacing to our text, what happens to the ligature in this case? Do we apply spacing to the ligature? So do we actually disable this ligature and put the spacing in between those glyphs at this point? And this is what we actually do on Android for larger letter spacing. We actually we disable ligatures and we use the spacing. Another example will be with Arabic, where a single code point can actually result into multiple glyphs. So depending on the position within the words, we should be choosing different glyphs. So in this example, you can see 4 different Arabic letters using 4 different glyphs for 4 different positions: start, middle, end of the word, or isolated. And finally, another example is bidirectional text that I already mentioned, is where you have left to right and right to left text in one layout. And in this example, we have Hebrew and English characters in the same text. And the main task when dealing with the bidirectional text is to define the order of the characters. In fact, bidirectional text has 2 orders, the logical one and the visual one. Logical one, the order in which we actually store the code points in the memory, but then the visual ones in the order in which we want to display them on the screen. So you have only left to right characters, like in English, the logical and visual orders are equal. But then if you have right to left characters only, the visual order is the opposite to the logical, as you can see. And finally, when you have a mixture of those, it gets complicated. Okay, so as you can see, text render is quite complex, but UI frameworks like Jetpack Compose are trying to abstract this away and to provide APIs that are friendly to the developers. So before jumping to some of those APIs, let's also have a quick recap how the text stack looks on Compose, now that we talked about how it actually renders on Android. So the entry points to the Compose text rendering stack is text composable for Material 3 library, or basic text if you're using Foundation, so it's like theme independent library, and Material under the hood will actually use basic text, just applying theme on it. And then inside basic text, we create a shim layout node and a modify. And the modify actually bears the main load of measuring and drawing the text. And during measure, we create something called multi-paragraph. That is a result of text being measured, and it can be drawn onto the canvas. Multi-paragraph then consists of a few paragraphs. And so paragraphs are very similar, but they can only have a single paragraph style in a given text. And paragraph style is something that includes properties like indentation, line breaking, alignment, line height, etc. And so at this level, we also do a lot of caching, so that if you call the measure with the same parameters, or more accurately say with the parameters that don't affect the measure result, non-layout affecting, we won't remeasure. And finally, paragraph will actually create the static layout, which is an entry point to the platform code that we already discussed. So this is the text stack on Compose side. So now that we understand that, let's talk a bit more about the text layout and explore some of the Compose APIs that give you a bit more control over text layout. Please know that this is not a comprehensive list. I've actually omitted most of the APIs that are very, easy to use and straightforward, and you probably already know them. Okay, so raise your hand if you ever had a situation where designer gives you some design spec and you can't really implement it, right? Yeah. Yeah, a good example here is like centering a text inside the button. This gets especially hard when you're also applying like line height specified by the designer. So let's see why this might be a problem and what Compose proposes and how Compose proposes to solve this and what APIs we have. So okay, so you have a design spec that says to apply 2em line height. But what does it exactly mean and where the things go wrong? Intuitively, we understand what the line height is, but let's give a formal definition. So the line height is the vertical distance between the two lines of text measured from baseline of one line to the baseline of the other line. And if you don't remember, the baseline is this invisible line that sits upon which all of the letters in the typeface sit. If you remember those ruled papers that we used like in primary school to learn how to write, so those lines were actually baselines. Okay, so but if you only have a single line of text, what does the line height mean in this case? Because you don't have another baseline to refer to, right? How do we set the line height in this case? So in this case, we actually end up adding a bit to the top and a bit to the bottom to make up for the desired line height value. But then the problem here is that when designer asks you to set that 2em line height, they may or may not want to add that additional line spacing to the top of the first line or to the bottom of the last line. Maybe they even don't know they might even have different distribution of that line spacing in mind. So for example, in Google Docs, that's on the left, example on the left, all of the additional line spacing, which is shown in green, actually goes to the bottom of the text. But in CSS, it's equally distributed between the top and the bottom. And some designers you might work with have different meaning or intentions in mind. And furthermore, the design tools that they use might have different behavior. But likely in Compose, we have an API that allows you to manipulate the line height and line height distribution. This API is called line height style. It has 3 parameters: the alignment, trim, and mode. So let's have a look at each of those. So alignment basically says how to distribute that additional line height spacing in respect to the top and bottom of the line. And there are 4 types: proportional, top, bottom, and center. So proportional means that we distribute the additional space proportionally to the font's ascent-descent. Practically, it means that we put a bit more to the top than to the bottom. Alternatively, you can use the bottom alignment, so all of the additional space will go to the top. And similarly, if you align to the top, then all of the additional space goes to the bottom. And then last but not least is center alignment. It means half and half, so half goes to the top, half goes to the bottom. So this is the alignment. Now, if you want to manipulate that first and last line, and you want to remove that additional spacing that we added to the first top of the first line and bottom of the last line, you can do this using the trim parameter. You can either remove it from the first line only, from the top of the first line, from the bottom of the last line. You can keep both, or you can remove both. Okay, so how do you actually center then? So you can consider using one of those 2 options. You can either trim both, or you can actually use the center alignment. But also know that centering is kind of very subjective because it depends pretty much on the font that you're using. Okay, there is this last parameter. This is an addition in the latest Compose API, and it's called line height mode. This was motivated by the tool scripts. The line height is very font dependent, and if you set the line height to a specific value, and this might actually be smaller than what the font metric actually wants for this. So in practice, it would mean that tool scripts will be clipped, as you can see here. So we introduced a line height mode API, and the new value is minimum, and the other fixed is the default behavior that we had before. So when you set line height and the value specified is too small than the one the system wants, then we will fall back to the system's value. Okay, so you might be wondering why this wasn't an issue before, because we only added this API in Compose 1.7, and I mean, you probably didn't receive that many complaints about this issue, especially with tool scripts. And the reason being that we had a special treatment for these toll scripts on Android side. We introduced something called UI fonts. So basically, like if you had a toll script, we had a special font that would actually squash it a little bit so that it fits into Latin-based scripts, so you can see on the right. But it's not very well maintained. It actually created a lot of readability issues, and so we finally getting rid of it. And now that Android actually can display since many years, toll scripts, it should be fine. Also know that this issue with the clipping of this line height can actually appear on the Latin-based scripts as well, like if you really send a very small line height compared to what font really wants. So using your minimum mode, line height style mode, is your best bet here. Okay. So I kind of told you that you will now be able to kind of easily achieve what designer wants from you. One thing to keep in mind, though, but not necessarily to act upon, is you should know about the nonlinear font scaling. So if you don't know, font scale is an accessibility feature where developer can increase the font size across all apps on their device. It helps really with to the user with visual impairments, or for anyone who actually prefers, bigger size, font size for easier reading. And so with the nonlinear scaling, when font is larger, it scales less than when it's smaller, and scaling will be applied to the line height too. But the problem with here is that, like, if you apply the same scaling algorithm to the line height, and your line height is specified in SP, like scalable pixels, the problem is that will apply this font scale algorithm, and so the line height will scale a little bit less than the font scales. And so you will lose this ratio line height to font scale. So like it was 2 EM before we scaled, but it won't be 2 EM, 2 times after we scaled. So it looks kind of squashed, and also it doesn't reflect the UX that your designer wanted anymore. So to fix this, we don't scale line heights defined in SP similarly to how we do font size. Instead, we keep the proportion. So we scale the font size, and then we apply that original proportion to the line height. And this way, we keep the proportion. Okay. One other thing that would help you to achieve a kind of polished look when working with text is aligning by baselines. If you have 2 or more text in a horizontal layout. Say you have here text and the text button in the row container. So most of the time you want to align them by baseline. So to do so, you use the align by modifier. Okay, so I've already mentioned readability when talking about translating your app into different languages. And how you should be thinking about toll scripts. But generally speaking, when building an app, you need to be aware of where this app will be run, what locale's user device is, and what form factors it's been used on. So if text looks good and reads well on a 6-inch phone screen, will it be as readable on 1.2 inches watch screen? Or what if I'm translating my app into other languages, will be as readable? So another factor that could affect the readability of the text is line breaking. So line breaking, as the name suggests, is the process of dividing a blob of text into multiple lines. In Compose, we have an API to help adjust the line breaking called the line break. It's a high-level API, and it's use case-based, as you can see from the names. So simple, the default in Compose, when none is specified, mostly because it makes sense for the text field, because we don't want to overflow every time we type a new letter or a new character. But also we resolve this unspecified value without any context, whether it came from the text or text field. So we use simple. So the line break itself, API, consists of 3 parameters. It has strategy, strictness, and word break. So to understand a bit more what each means and when to use each, let's actually have a look how the line breaking happens. first, we need to understand position in text where we can break, so to speak. They are appropriate places to start a new line, and they are called break opportunities. So after we define that set of opportunities, we need to choose from that set a few where we will actually break. And this is basically what the breaking strategy does. Okay, so we define three strategies in Compose: simple, high quality, and balance. For simple breaking strategy, we run a simple greedy algorithm. So as soon as you reach the end of the available width, we break into next line on the nearest opportunity. High quality and balance are a bit more complex. Under the hood, both of them use dynamic programming to solve the minimization problem. Android adopted this line breaking algorithm for the text typesetting program. You probably heard of it. So the algorithm tries to minimize a total amount of spaces across all of the lines altogether. So high quality is actually the recommended one to be used in most cases, apart from text field that I mentioned. And the balance strategy is very similar to high quality, but it also aims to distribute white spaces evenly, including the last line, which the high quality doesn't. So the balance strategy, as you can see on the right, it's a bit more balanced. It was motivated by small screens because they have less space, and so you need to be more diligent about how you distribute that space. Okay, so now that we know what algorithm we use to break those lines, let's come back to the breaking opportunities and see how we choose those opportunities. For some of the languages, defining breaking opportunities is very easy. It's just, for Latin languages, for example, it's just white spaces, especially if you don't use hyphenation. But for languages that don't use white spaces, for example, Japanese, how do we do this? So we use the Unicode to help us define those opportunities. We use it through the ICU library that I mentioned at the beginning of my talk. And you as a developer actually have the opportunity to influence this as well. So one option is you of course could do manually, and you could put soft or hard line breaks manually in every places where you want to break, but of course it's not very practical. So we want an automatic way. And so we expose an API called the line break strictness. This will have effect on languages like Chinese or Japanese, those that don't use white spaces for word bounds. Basically, strictness defines the using the linguistic rules where we can actually break. And there are strict, normal, and loose, and they follow the same meaning as in CSS, so we mirror them here. On practice, strict means that you'll have less breaking opportunities, and loose will mean that you'll have more breaking opportunities. And the default is the one we decided for you based on locale and some other parameters. Okay, so we also provide another API that tries to find the line breaking opportunities in languages like Japanese by separating into meaningful chunks to provide beautiful line breaks. And under the hood, these APIs uses machine learning. Okay, so the recommendation we give here is that you try use this high-level line break API, because in that case we set all of those other internal those parameters that I've discussed for you, and these are use case basis, so it's kind of easier for you to know which one to use. But we also suggest you test your app in different locales and screen sizes to verify that the line breaking actually makes sense for your app. Okay, so now that we've talked about Compose Text Stack, we discussed how to make your static text readable in different contexts. But text is much more, and you may want to add some interaction over it or special effects, so let's talk about it. Say you want to implement a UI like you tap on a word and you have a pop-up that translates this word. Or for example, like in here, you highlight part of the text with some custom underline for the words that have typos in them. So for all of that, you will need to know the coordinates of a word, the substring in the original string. And for that, we have an API to help you with that, and this is called text.result. So text.result is the class that holds information about the measured text. You can see all of the different parameters that it has. It's like only a few of those. Let's see how to use it. So, for example, we implement the app that I've told you about already. So you click. So you have this kind of Duolingo-like app where you want to translate. You learn a new language. You want to translate the sentence, and you don't really know the meaning of one of the words. You tap on it. You get your translation. So how we implement this? So here I displayed well, it's a lot of code. You don't really need to read all of that, but like the most important bit is this text, which the string that we display. So I put this string and I apply input pointer modifier so that I call this tap to translate. So when a tap gesture is detected, I might update my UI and show a pop-up. But at this point, I will need to actually show in translation. So I need to know where we tapped and get the word that we've tapped on. So how do I get this word from this tap location? So first of all, I have this translation. I have this state class that I've created that holds text.result for me. And so when the tap happens, I get a position inside the layout node where the tap happened. From that, I need to understand which character it is actually, and I do this by using getOffsetForPosition API from text.result. And then when I have an offset in the string where it was tapped, I need to know which word this offset belongs to. So I use another API called getWordBoundary, and then this gives me a text range. From that, I get my substring that is actually a word, and then I send it for translation. One bit that needs to be done to make it work is that I need to actually set that text layout result. So to do this, I do it inside on text layout, call back inside the text composable. And so we are done implementing this sample. So Compose constructs this text layout result object during the layout phase. So if you have some logic that depends on text layout result in composition, you will get a 1 frame delay initially when there is still no text layout result. So in previous example, it's not an issue because we only display the translation as a result of click, so it happens after this whole composition, layout, and drawing phase is completed. But let me show you a slightly modified example where you will actually hit this 1 frame delay. So say we have a very similar example, but now we have some of our words already have translations, and we want to show it with sparkles, and whenever a user taps on it, we want to show the translation again. So as you can see, it's pretty similar to previous code, but it's a bit different. So here in composition, we use text layout result. If it's not null, then for every translation that we have, we show some sparkle badge. So when the first composition happens, as you can see, text layout result is still be null. And it will only be created during the layout phase. And during layout phase, we will update it. And because text layout result is actually an observable state that we read inside the composition, when we updated it, the composable function will be rerun. And so at this point, text layout result is not null anymore, and so we'll display our badges. So this kind of 1 frame delay is quite unfortunate, but there is not much you can do about it apart from like changing your UX. But it's important to note that if you only need to use this text layout result for drawing, then you will not get this 1 frame delay anymore, because drawing phase happens after the first measure happened. So in that case, you will not get 1 frame delay. So here, this is the same app, different examples. So say you want to draw this custom underlines. We have an underline in text style API, but this underline doesn't give you a lot of flexibility. So say you want to draw a bit custom. So how would you do that? So as similarly to the previous example, we have this state class that holds our text layout result that we set inside on text layout callback this text layout result. And so this time we will not read it in the composition, but instead we will apply a draw modifier to our text composable. And then inside this draw modifier, we will read the text layout result. So by the time this draw happens, text layout result is already there. Okay, so I just want you to remember what are those common issues when you use text layout result, because there are quite a few. Some of them I already mentioned. So first of all, as I said, like if you are doing it in draw, it's fine. By the time the draw kicks in, you already have your text layout result. But if you're using in composition, you need to be aware of that 1 frame delay. And this 1 frame delay will not only happen like initially. So say, for example, that you displayed your text, you have your text layout result calculated, but then your new text comes. So inside the composition, you will check text layout result. It's not null, but the problem that text layout result belongs to the old text, not to the new one. So, for example, if you use some offsets and the texts are different lengths, then you will actually get index out of bounds exception. So it's very important that you actually invalidate text layout result correctly. And another consideration when doing a lot of this custom stuff with text layout result is that you need to think about right to left layouts, languages, because we do have APIs that help you and provide you right to left support, but you need to be sure that you actually don't constrain all of your calculation to left to right. Okay, so let's now talk about the custom drawing of the text. Custom drawing allows you to draw directly on canvas, so it might give you more flexibility and control. So, for example, we're building a chart library. We're going to draw all of our chart on canvas, and for labels, we'll use draw text as well. So, in this is an example how would I then use my chart library inside a Sum Finance app. So, how do we implement this? Say there is a draw text method defined on the draw scope. So in our case, we want to draw every label. So you saw like Tuesday, Wednesday, whatever. So for each of those labels, we need to call the draw text. And we need to pass the text layout result to it and also the top left offset. And so to get that text layout result, you actually need to measure your text, your label first. So how do we do this? We could use some lower level APIs, the one that I've mentioned before, like static layout, for example, but then you will need to do a lot of stuff manually. So for your convenience, for developers' convenience, we provide a API, a class called text measurer. So text measure responsible for measuring text, so it's ready to be drawn. So let's explore some characteristic of it. So you have text measurer has a constructed with a default font family, density, layout, direction, and cache size. For everything apart from the cache size, we can't provide a good default outside composition. So normally you would create your text measure inside, create and remember your text measure inside composition, and for each of those you will provide composition locals corresponding to each of those. So now the cache size. So you've heard today that laying out text involves a lot of steps, and it's an expensive task computationally. And so text measure actually holds a cache of layout input to measured result pairs, so that if you call measure calls multiple times with the same parameters, we will not to remeasure. Now that cache size by default is 8, but it actually the value you will provide depend on your use case. So for example, if you're using one text measure to measure multiple text one by one, like we're doing in our example, where we need to measure multiple labels, then you need to provide the cache size at the number of those a number of text that you are going to measure. But for example, if you're using text measure to animate the font size, then having a cache really doesn't make much sense, because all of those repeated measure calls will actually miss the cache anyway. Okay, so coming back to our example, so we define our text measure inside composition using remember text measurer, and we pass it to the drawbar chart function that we have. and knows that I've already mentioned the cache size that we provide. It's labels.size, so the amount of labels that we have. One thing to note, though, that these labels can be really huge, right? Like there can be too many data, and so you will store a lot of resulting in memory, and so you need to just be aware of it. But even if you skip the cache, you will still get that platform level caching that I mentioned earlier, where remember we have this shaped words, we store them in cache and platform. Okay, so this was our drawing example. One thing to know when doing custom drawing is that you lose functionality that normally would come with the basic text, and you will need to consider to put this back depending on your use case. And the most noticeable thing here is semantics. So it means that by default, your text won't have accessibility support anymore and very limited testing capabilities. So to address it, we would recommend you look into how we implement semantic inside basic text and see what semantics you could put back. If that's not possible, like in our case with the chart, then at least make sure you provide a content description, semantics. Okay, so to summarize this whole story about the text layout result and text measure, let's define kind of general rules or use cases when you should be using them. So if you display a text using a text composable and you need to use text layout result, you need to add some additional capabilities on top of that, some additional functionality, then using text layout result from the onText layout callback is the thing to do. Text measure in combination with a draw text is used for custom drawing, another thing. Text measure could also be used for early measuring some text to then align or constrains a text composable. Such a use case could be, for example, implementing your outer size support, or your very kind of famous UI where you have a text ellipsized, and after the ellipses you put a more button. We don't have out-of-the-box support for this, so if you are going to implement this, then text measure is something you would, and text layout result is something you would reach to. Okay, so to finish this talk, let me tell you what changes are coming to text to Compose 1.8. Okay, so firstly, I was checking that you can implement outer size using text measure. Well, in reality, you won't need anymore. As Roman told you, asked you, or suggested in his talk earlier, please do update to latest Compose version. And yes, so if you do update to 1.8, when it will go stable, you will get an outer size support. So we've added this to basic text composable, so now you have a parameter outer size. Yeah, please note that this API might change slightly, when we go stable, so just keep this in mind. So we also did a lot of performance work. Roman mentioned in his talk. Outside that work, we also did a lot of stuff inside text, and we will continue doing this beyond 1.8. We also did some changes to the annotated string to allow better support for custom markdown renderers. Most notably, we opened a constructor that takes all annotations, and these are annotations and styles. They are together. They are actually now kept in a single list in order. And also, we now allow fully nested and fully overlapped paragraphs, something that you were asking for and we didn't have before. Okay, so this is it from me. If you have any feedback about the API, want to report a bug or a feature request, as always, please use our issue tracker. And if you have any questions, Kotlin Slack is one of the best ways to reach out. With that, I will finish my talk. Thanks for listening. I hope you have a great droidcon London. Thank you.